A mirage is a naturally occurring optical phenomenon in which light rays are bent to produce a displaced image of distant objects of the sky. The word comes to English via the French mirage, from the Latin mirari, meaning to look at, to wonder at. This is the same root as for mirror and to admire. In contrast to a hallucination, a mirage is a real optical phenomenon that can be captured on camera, since light rays are actually refracted to form the false image at the observer's location. What the image appears to represent, however, is determined by the interpretive faculties of the human mind. For example, inferior images on land are very easily mistaken for the reflections from a small body of water. Mirages can be categorized as inferior, superior, and fata morgana, one kind of superior mirage consisting of a series of unusually elaborate, vertically stacked images, which form one rapidly changing mirage. Inferior mirage. For exhausted travelers in the desert, an inferior mirage may appear to be a lake of water in the distance. An inferior mirage is called inferior because the mirage is located under the real object. The real object in an inferior mirage is the sky or any distant object in that same direction. The mirage causes the observer to see a bright and bluish patch on the ground in the distance. Light rays coming from a particular distant object all travel through nearly the same air layers and all are bent over about the same amount. Therefore, rays coming from the top of the object will arrive lower than those from the bottom. The image usually is upside down, enhancing the illusion that the sky image seen in the distance is really a water or oil puddle acting as a mirror. Inferior images are not stable. Hot air rises, and cooler air descends, so the layers will mix, giving rise to turbulence. The image will be distorted accordingly. It may be vibrating, it may be vertically extended or horizontally extended. If there are several temperature layers, several mirages may mix, perhaps causing double images. In any case, mirages are usually not larger than about half a degree high and from objects only a few kilometers away. Heat haze, also called heat shimmer, refers to the inferior mirage experienced when viewing objects through a layer of heated air. For example, viewing objects across hot asphalt or through the exhaust gases produced by jet engines. When appearing on roads due to the hot asphalt, it is often referred to as a highway mirage. Convection causes the temperature of the air to vary, and the variation between the hot air at the surface of the road and the denser cool air above it creates a gradient in the refractive index of the air. This produces a blurred shimmering effect, which affects the ability to resolve objects, the effect being increased when the image is magnified through a telescope or telephoto lens. Light from the sky at a shallow angle to the road is refracted by the index gradient, making it appear as if the sky is reflected by the road's surface. The mind interprets this as a pool of water on the road, since water also reflects the sky. The illusion fades as one gets closer. On tarmac roads it may look as if water, or even oil, has been spilled. These kinds of inferior mirages are often called desert mirages or highway mirages. Both sand and tarmac can become very hot when exposed to the sun, easily being more than 10 degrees Celsius hotter than the air 1 meter above, enough to create conditions suitable for the formation of the mirage. Heat haze is not related to the atmospheric phenomenon of haze. Superior mirage. A superior mirage occurs when the air below the line of sight is colder than the air above it. This unusual arrangement is called the temperature inversion, since warm air above cold air is the opposite of the normal temperature gradient of the atmosphere. Passing through the temperature inversion, the light rays are bent down, and so the image appears above the true object. hence the name superior. Superior mirages are in general less common than inferior mirages, but, when they do occur, they tend to be more stable, as cold air has no tendency to move up and warm air has no tendency to move down. Superior mirages are quite common in polar regions, especially over large sheets of ice that have a uniform low temperature. Superior mirages also occur at more moderate latitudes, although in those cases they are weaker and tend to be less smooth and stable. For example, a distant shoreline may appear to tower and look higher than it really is. Because of the turbulence, there appear to be dancing spikes and towers. This type of mirage is also called the Fata Morgana or Hafjadingar in the Icelandic language. A superior mirage can be right side up or upside down, depending on the distance of the true object and the temperature gradient. Often the image appears as a distorted mixture of up and down parts. Superior mirages can have a striking effect due to the Earth's curvature. Were the Earth flat, light rays that bend down would soon hit the ground and only nearby objects would be affected. Since Earth is round, if the downward bending curve is about the same as the curvature of the Earth, light rays can travel large distances, perhaps from beyond the horizon. This was observed and documented for the first time in 1596, when a ship under the command of Willem Barend Essed in search of the Northeast Passage became stuck in the ice at Nova Zembla. A crew was forced to endure the polar winter there. They saw the midwinter night come to an end with the rise of a distorted sun about 2 weeks earlier than expected. It was not until the 20th century that science could explain the reason. The real sun had still been below the horizon, but its light rays followed the curvature of the Earth. This effect is often called a Nova Zembla mirage. For every 111.12 kilometers the light rays can travel parallel to the Earth's surface, the sun will appear 1 degree higher on the horizon. The inversion layer must have just the right temperature gradient over the whole distance to make this possible. In the same way, ships that are in reality so far away that they should not be visible above the geometric horizon may appear on the horizon or even above the horizon as superior mirages. This may explain some stories about flying ships or coastal cities in the sky, as described by some polar explorers. These are examples of so-called Arctic mirages, or hillingar in Icelandic. If the vertical temperature gradient is plus 12.9 degrees Celsius per 100 meters, then horizontal light rays will just follow the curvature of the Earth, and the horizon will appear flat. If the gradient is less, the rays are not bent enough and get lost in space, which is the normal situation of a spherical, convex horizon. In some situations, distant objects can get elevated, alert, stretched, or shortened with no mirage involved. Fata Morgana, a Fata Morgana, the name of which comes from the Italian translation of Morgan Le Fay, the fairy shape-shifting half-sister of King Arthur, is a very complex superior mirage. It appears with alternations of compressed and stretched zones, erect images, and inverted images. A Fata Morgana is also a fast-changing mirage. Fata Morgana mirages are most common in polar regions, especially over large sheets of ice with a uniform low temperature, but they can be observed almost anywhere. In polar regions, a Fata Morgana may be observed on cold days, in desert areas and over oceans and lakes. A Fata Morgana may be observed on hot days. For a Fata Morgana, temperature inversion has to be strong enough that light rays curvatures within the inversion are stronger than the curvature of the Earth. The rays will bend and create arcs. An observer needs to be within an atmospheric duct to be able to see a fata morgana. Fata morgana mirages may be observed from any altitude within the Earth's atmosphere, including from mountaintops or airplanes. A fata morgana can go from superior to inferior mirage and back within a few seconds, depending on the constantly changing conditions of the atmosphere. 16 frames of the mirage of the Farallone Islands, which cannot be seen from sea level at all under normal conditions because they are located below the horizon, were photographed on the same day. The first 14 frames have elements of a fata morgana display, alternations of compressed and stretched zones. The last 2 frames were photographed a few hours later around sunset. The air was cooler while the ocean was probably a little bit warmer, which made temperature inversion lower. The mirage was still present, but it was not as complex as it had been a few hours before sunset, and it corresponded no longer to a fata morgana but rather to a superior mirage display. Distortions of image and bending of light can produce spectacular effects. In his book Pursuit, The Chase and Sinking of the Bismarck, the author Ludovic Kennedy describes an incident that allegedly took place below the Denmark Strait during 1941, following the sinking of the Hood. The Bismarck, while pursued by the British cruisers Norfolk and Suffolk, passed out of sight into a sea mist. Within a matter of seconds, the ship reappeared steaming toward the British ships at high speed. In alarm, the cruisers separated, anticipating an imminent attack, and observers from both ships watched in astonishment as the German battleship fluttered, grew indistinct and faded away. Radar watch during these events indicated that the Bismarck had in fact made no changes of course. Nighttime mirages. The conditions for producing the mirage can take place at night. Under most conditions, these are not observed. However, under some circumstances, lights from moving vehicles, aircraft, ships, buildings, etc., can be observed at night, even though, as with a daytime mirage, they would not be observable. This includes the mirage of astronomical objects. Mirage of astronomical objects. A mirage of an astronomical object is a naturally occurring optical phenomenon, in which light rays are bent to produce distorted or multiple images of an astronomical object. The mirages might be observed for such astronomical objects as the Sun, the Moon, the planets, bright stars, and very bright comets. The most commonly observed are sunset and sunrise mirages.